Hello, I'm Teacher Ivan from Wuna Educational Services. I welcome you to our fourth lesson. We are still looking at linear motion, and probably this is the last part of linear motion. However, if at all you missed the first, please go to our playlist, go to A-Level Physics 1, scroll down, watch the previous videos so that you catch up with us and we move together. In this particular lesson, we shall be looking at motion under gravity. Motion under gravity is when a body is moving vertically upward or vertically downward. When you throw a piece of chalk, it accelerates or decelerates vertically upward, and then after reaching a maximum height, it comes back. So motion under gravity is therefore categorized into two. That is vertical motion, whereby we have vertical upward motion and vertical downward motion. Then the other type of motion under gravity is a projectile. So when we are looking at motion under gravity, we shall look at the vertical motion and then projectile, because in projectile also a body is given initial velocity and left under the influence of gravity. So we shall start with the vertical motion, where we look at motion upward or motion downward. During the upward motion, the acceleration equals to negative g, simply because the body is against gravity, and that the body's velocity goes on decreasing until it becomes zero when the body is at maximum height, and then the body will be forced to come back down. And during come back, it's when we have the acceleration as positive g, and it's what we call vertical downward motion. So for vertical upward motion, we shall modify the three equations of motion and replace A with negative g. For upward motion, we replace A with negative g in the equations of motion, such that the first one becomes v equals to u minus gt. The second one becomes s equals to ut minus a half gt. And the third one becomes v squared equals to u squared minus gh, where h is the maximum height reached by the body before it comes back, because it has to come back. So those are the equations for vertical upward motion. Then let us also look at the vertical downward motion. During the vertical downward motion, acceleration is positive g, because the body is obeying gravity, or it's in the same direction as the gravitational force. So we modify the equations and replace A with G. Therefore, the first one becomes V equaling to U plus GT. The second one becomes S equals to UT plus a half GT squared. And the third one becomes V squared equals to U squared plus 2GH, where still H is the maximum height reached. So on this, we have examples. The examples are, number one, we are told that a ball is thrown vertically upward with an initial velocity or speed of 20 meters per second. And now they want us to calculate the time taken to return to the thrower and the maximum height reached. So this is how we get the time taken to return to the thrower. Let us first sketch this. So this is our ground where the thrower is. He throws a ball up and comes back. This is what we call maximum height, h. And at that point is where v is 0. But this one is given an initial velocity. So during the upward motion, it takes time t1. When it reaches maximum height, it comes back and it takes time t2. So to get the time when it returns to the thrower, it means that time is capital T, which we can also term as time of flight, which is given by T1 plus T2, because it goes and comes back. But surprisingly, T1 should be equal to T2. Why? Because the initial velocity here becomes the final velocity here. So as the velocity goes on decreasing up to 0, then on reaching the maximum height and returning back, the velocity goes on increasing from 0 until the value that it had before. So if it had 20, the final here will also be 20. And therefore, even the time will be the same, because the value of g, or the acceleration there, is constant. So that means that to get the time it returns to the thrower, we need to just get the time it takes to reach the maximum height. So we shall say from v equals to u minus gt, because it is going up. Our v is 0, our u is 20, minus gt 1. Therefore, we cross multiply. When we take this one the other side, it becomes negative 20 equaling to negative gt 1. And when we divide by negative g, we shall get that time as 20 over g. That's the time it takes to reach the maximum height. The total time, the time it takes to come back to the thrower, will be given as twice t1, which is twice 20 over g, hence giving us 40 over g seconds. So that is the time it takes to come back to the thrower. The other question was asking for the maximum height reached. For maximum height, remember, at maximum height h, the final is 0. And therefore, from the third equation, which says that v equals to, this is v squared equals to u squared plus 2as. Therefore, it will be v squared equals to u squared minus 2gh. Since it is going up, it is a minus. And the final is 0. The initial was 20 squared minus 2gh, which gives us negative 400. When this one comes this side, it gets us negative 400 equaling to negative 2gh. We make h the subject, which is 400 over 2gh. The negative cancels out. which gets us 200 over G, and this will be in meters. So you can always substitute with the value of G and get the numerical value. So that is how we work out numbers on vertical motion. It can be vertical upward or vertical downward. So please, on this very note, I request you to try out the second number. It seems to be a bit different. Maybe we can still do the same. I'll leave you with some trial numbers. This number 2 says, a man stands on the edge of a cliff and throws a stone vertically upward. So, a cliff is a raised platform above the ground. So we shall take this as our cliff. The man throws a stone upward and it passes the point of projection and it lands on the ground. So this one is given an initial velocity of 15 meters per second, and we are told that after what time will the stone hit the ground, that is 20 meters below the point of projection. So the ground is 20 meters below the point of projection. And therefore, how do we get time? There is an easiest way of getting this. We shall consider this as the distance traveled by the stone below the point of projection. And therefore, since it is below the point of projection, from S equals to UT minus a half GT squared, the 20, but negative. It's negative because it is below the point of projection, equals to the initial was 15t minus a half GT squared. So we shall have, when we multiply throughout by 2, we shall have negative 40 equaling to 30t minus GT squared. You realize that we can form a quadratic equation which can be solved to get the values of t. That is how we get that time taken. So please, that has been motion under gravity. I beg to leave you with some trial numbers. So you try out these numbers. Number 1 says, number 1 part A is asking for the Newton's laws of motion. You should state them clearly. Then they want us to explain how a rocket is kept in motion. You can research about it. Number 2, part A, they want us to define a uniformly accelerated motion. We looked at that in our first lesson. And part B is asking us to describe the motion of a body projected vertically upward with the aid of a velocity time graph. And the part C is a calculation number where you must get the answer as 11.5 seconds when you try out. Otherwise, that has been linear motion. So please make sure you try out. Make sure you add on more numbers. Please don't stop on what you have looked at, add on others. Otherwise, I request you to always subscribe to our channels. Go to homepage, scroll down, you find those channels, subscribe to them so that we learn together.